Hello friends, in this lecture we're going to create the enemy. So first of all, let me just walk you through how the enemy is going to work, and then we're going to switch over to Unreal and start creating it. So first of all, the enemy, just like the player, is going to have a sprite component and a capsule component for the collisions. So that part is going to be the same. The enemy is going to also have some movement code, which is also going to be very similar to the player. We're going to calculate the new location, and we did this in the player by getting the current location and then adding the movement that we calculated. In this case, that's going to be the movement direction times the movement speed times delta time. So this part is also going to be very similar. In the player, of course, we had this in a two-step process because we were checking for the map bounds, but in this case, since the enemy is not going to have any limits because we want the enemy to be able to go through the map, we're not going to do it in a two-step process. We're also not going to check for any limits. So this part is going to be extremely similar and much more simple compared to the player, because this time also we don't need to do any input. The only input the enemy is going to have is going to be the movement direction, and that input will be given to the enemy when we create the enemy. So let's also talk about that part a little bit. So let's say that this here is the game area. Before we create an enemy, we're going to pick a random location on the edges of the game area. So let's say here. After we create the enemy, we're going to put the enemy at this location, and then we're going to give the enemy a random direction, which is going to be based on the direction of the player. We might even just use the player's direction actually. Yeah, maybe straight up just use the player's direction. So let's say that the player was here. We'll give the enemy that direction and we'll send the enemy in a straight line. And if the enemy is able to touch the player, in that case the player is going to lose the game. So that's about it when it comes to the enemy. And also one more thing, the sprite of the enemy, which one we use, because we have 3 different enemy sprites, that's also going to be random, but that's going to be done from the enemy spawner, so we're not going to do it in this video. Okay, so this is the enemy. Let's go ahead and start implementing this. So first of all, we're going to create a new C++ class, and that class is going to inherit from the actor, because this time we don't need to possess it, so it can simply be an actor in the game. And the name is going to be enemy. But I already created this so that we can save some time. But you should go ahead and create this class. Let's go into Visual Studio and start implementing this class. It's going to have a ton of similarities with the player, so we can actually do some copy and pasting here to save time. First of all, I'm going to copy and paste these include statements at the top, so that we can create the components, which I'm also going to copy and paste from here. Just like that. Let's also copy and paste some of the variables. So we're going to use the movement speed as well as the movement direction. Let's get those in here. And for the enemy, we're also going to create a timer. So for that, we're going to include the engine timer handle.h. And down here, we're going to create the timer, which is going to be an ftimer handle. We're going to call this the destroy timer. We're going to create a function for this destroy timer to call as well down here. And that's going to be void on destroy timer timeout. We can also create a float here that's going to control how long the destroy timer is going to go for. We can also do that. So up here we'll create the destroy timer duration float, which can be something like 5 seconds by default. And of course we can adjust this from the editor if we don't like it. Great, so that's all we need in the header file. Let's create the timers function in the CPP file. And then we're going to start implementing the rest of the code. First of all, we're going to create the components in the constructor, which is something we can copy and paste from the player. It's going to be exactly the same. Next up, let's set up the timer stuff. So at the start of the game, we're going to start the timer, or when we create the enemy rather, not the start of the game. So in begin play, when the enemy is created, we're going to set the timer, and when the timer times out, we're going to call destroy so that we get rid of this enemy, because if we end up having too many enemies and we don't destroy them, at some point that's going to cause some performance issues. In order to set the timer, we're going to call getWorldTimerManager dot set timer. This is going to take in the name of the timer, destroy timer, then it's going to take in this, and after that it's going to take in the address of the function that we want to call. So ampersand, the name of the function. Then we're going to say 1 here, false to the loop, and then finally the delay is going to be destroy timer duration. So this delay here is not important because this timer is not going to loop. So this boolean controls that. If it were to loop, this time here would be used after the first time it times out. But since it's not going to loop, only this float here that we give is going to be used for the timer's, timeout duration. Okay, so this should be working, and that means the only thing we need to do here is the movement code here in tick. So at the end we want to call set actor location with the new location. And the new location is going to be an effector. And we should also calculate the distance to move, which is going to be an effector 2D. Okay, so distance to move is going to be the movement direction times the movement speed times delta time. And then of course the new location is going to be the current location, which we can get by calling getActorLocation plus an effector that we're going to create with distance to move. Just like that. So exactly the same thing we did for the player. Well, of course here we don't care about the map bounds. So we're doing it in one go. We're taking the current location and we're increasing the X and the Z positions by the calculation we made up here. And since the enemy is always going to move, it's never going to stop. We don't need to do any kind of checks here in tick. This should always get called, and the direction will be given to the enemy when the enemy spawner, which is something we're going to create, spawns the enemy. Okay, so this is all looking good. And before we actually compile this, I also want to implement the collision between the player and the enemy. And we're going to do that from the player. So the enemy is not going to handle any of that. It's all going to be done from the player. So in the player, we're going to use the capsule components, one of the delegates of the capsule components. And that delegate is called onComponentBeginOverlap. That delegate, or you can also think of it as an event, will be fired when there's an overlap between this capsule component and some other actor's component, collision component. We can bind a function to that, and then we can tell Unreal to let us know whenever there's an overlap. So to do that, we're going to create the function first, and that function needs to have a specific signature, which I'm simply going to copy and paste because it's a very long one. I don't want to waste time typing this out by hand. It looks like this. We're going to create this in the CPP file at the bottom. Just like that. And then we're going to bind this function to that delegate I was talking about. And we're going to do that here in begin play. So let's get the capsule component. And we're going to take a look at onComponentBeginOverlap. This is an event or a delegate. We're going to call the add dynamic function. Not that one, this one. And this is going to take in, first of all, this and the address of the function that we want to bind, which is going to be overlap begin. Just like that. So now whenever this event is fired, this function down here is going to get called. And inside of this function, we have access to the other actor that we collided with or overlapped with, which is this argument here. We also have a bunch of other information, as you can see, but the only one we care about here is the other actor. First of all, we need to check if this actor that we're overlapping with is the enemy or not. We can do that using a cast. So let's go ahead and include the enemy.h here so that we can use the class name. And then we're going to say a enemy equals cast a enemy other actor. And if this works, that means the other actor we collided with is indeed an enemy. And in that case, we want to basically make the player not alive anymore. This is the end of the road, end of the game. And we're going to do that by turning off the player's sprite and taking away the player's ability to move. And to control that movement and to basically represent if the player is alive or not, we're going to create a Boolean variable in the player. So inside of here, we're going to create a visible anywhere variable called, a Boolean called is alive, which will be true by default. And then when the enemy touches the player, we're going to set this to be false. In fact, we'll check if we're alive first, because we don't want to try to kill the player more than once. If is alive is set to true, we'll set it to be false. And then we're also going to say sprite component set visibility false to turn the sprite component off. We're going to do more stuff here in the future, like playing a sound effect, and there's a little bit more stuff, but for now, we're going to leave it at this. We also want to, stop the player from moving when this happens, so we're also going to check for is alive in tick before we try to move the player. So we can create another if statement here and check for is alive, and then we can put all of this stuff in that if statement, just like that. Okay, so this should be everything we need to do. Now we're going to go into Unreal, exit, we're going to rebuild the game, and then of course we're going to create a blueprint for the enemy, and then we're going to test this. So let's go ahead and create a new blueprint for the enemy. Enemy. I'm gonna call it, you guessed it, blueprint underscore enemy. Open this up. And we're going to configure the components, of course. The sprite component and the capsule. For the sprite, we're going to use one of these enemy sprites we have. So I'm going to just pick the green one. And I'm going to switch over to the right view here. We're going to set the the material to be the translucent material. We're going to set the collision preset to be no for the sprite, of course. And we're going to set the sort priority here to be, let's see, 10. What did we set it for the player? Let's see. Let's take a look at the players. The players should be above the enemies. We did 10 for the player. So let's say 20 for the player and 10 for the enemies. Okay. Next up, we're going to set the capsule, which is going to have a half height of 35 and a radius of 35 as well. That should be good for all of the sprites we have. And let's see. And we can leave the preset as this one. That is just fine. The sprite is going to be set in the end randomly from the enemy spawner. So it's going to use one of those 3 different ones we have. But just for now, we'll use this green one inside of the blueprint. Okay. save and compile, and we can test this by putting one of these into the game. So let's drag one in. Let's make sure that the location, the Y position is 0, and then we can put it here, save and play the game. It's not going to move because the direction is 0, and it should also delete itself after 5 seconds, which works, as you can see. Awesome. Let's also try to touch it. When I do that, as you can see, the player just got killed. Okay, so finally I want to give this a direction from the code and actually see if the movement is also working. I forgot to do this before we compiled, so we're gonna go into the enemy, and in begin play we'll just set movement direction dot, if I can type, .x to be 1 and I don't know, y to be 0, so that it moves to the right. And this is just temporary, just a test. In the end, the direction will be given from the enemy spawner based on the position of the player. Okay, let's run live coding for this. Let's play the game. And as you can see, the enemy is moving. It's moving very slowly, so we should probably increase the movement speed. And I think a movement speed of 300 should be enough for the enemy. It shouldn't be faster than the player. Or maybe it should. It depends on what you want to do with the game. Yeah, so this speed should be okay. And with that, we're going to end this lecture. Thank you very much for watching. If you liked it, maybe consider subscribing to the channel. In any case, take care. I'll see you in the next one.